Welcome. This video focuses on getting things done with strings. So one of the issues with dealing with strings is we have so many tools available. For any given task, there's probably 3 or 4 different ways to get it done. So the challenge often is just picking the right tool so that you're making the job as easy as possible. So we're going to look at a couple examples of manipulating strings and give you a few tips. So the first task we're going to look at is deciding, does something look like an email address? Does it have an @ symbol in it? Well, the most straightforward way to do that is the find. And find is one of our essential building blocks. It looks at a string and tells us the location of a particular thing. So I say look for an @ symbol in my string, so mystring.find the @ symbol. It's going to start walking from the beginning and tell me, oh, I found that at location 3. If it can't find it, it can't return any of these values. If it returns 0, that means it's at the first location. If it returns 1, it means it's at the second character. So by convention, it returns something that's equal to -1. The ugly truth, and why we get a warning if we try doing that, is that what it's returning is actually the largest possible value. Mystring.find actually returns an unsigned value, something that is between 0 and a really large number. Now, it turns out that if you compare that with the signed value -1, those two are equivalent. But the proper way to do this, and the way you'll see in the book, is comparing mystring.find to string end position. Basically, this is guaranteed to always be the correct value for, hey, it's not there. But if you're coming from Java or some other language, you might be used to thinking this as, I find it, and if it's not there, then it tells me -1. But so kind of however we structure it, we can ask a string to find a particular thing, and if it's a number that's 0, 1, 2, 3, 4, something like that, then we know it's in the string. If it's the string end position, then we know it's not there. So say I've found that symbol, and now I want to replace it. Kind of multiple ways I could do that. So the first, assuming that I already know that the @ symbol is in my string, I could ask my string to find the @ symbol, to get that location and call that the index, and then call the replace function. Right? This is probably the most natural way to do it, to tell my string, okay, replace, starting at the location we just found, so starting at location 3, replace one character with the hashtag. And then we print it out, and we see we end up with this. Now you may be wondering, okay, how do I remember that my replace and find exist and what my possible options are? Well, there's a couple basic ones that you definitely should just memorize. You got to know find, you should know replace, substring, erase, a couple basic ones. But other than that, you get good at looking things up. So you use something like c++.com. It's a good reference site. And you go to the reference section and you find the string library. So I happen to know it's under other string. And I go look up, okay, where's string? String. So here's all the things that I can do with and to a string. And so I can find things in this list, go look up, say, what erase does, and find the description, find some examples. Getting good at looking things up when you're not sure about them is an essential skill, and this is really the first place where you're going to have to start using that. So this is not the only way I could accomplish this task, however. I could use the bracket operators, allow me to access a particular character to say, okay, go to my string and access character number 3 and assign it the value hashtag. All right? And so it will go, assuming we've found the location where the @ symbol is, we'll get 3, that'll be the index. This says change character at index 3 to the hashtag, and we'll get the same result. Replace is a little bit more flexible in that I can replace more than one character. and I could replace, say, 5 characters with just 1 character. I could replace 1 character with a huge string. But if I just want to replace 1 character with another, this version will work too. I could also make this a little bit longer and wordier, so I could find where the @ symbol is, and then I could build up the string by saying, okay, take the substring from 0 up, and I want 3 characters, so BOB is what I get for that, and then concatenate that with a hash symbol, and then concatenate that with the substring starting at index +1. So if I found this at 3, this says start at character 4, and since I haven't specified the end, or how many characters I want in this substring, it's going to assume I mean all the way to the end. And when we build up that new string, store that back into my string, and we'll end up with the same result. Right, a little bit more wordy, but it works. Say I want to break this up a little further. Right? I've got bob@a.com, and I want to break this into the username and the email's domain. Well, our basic tools for anytime we want to break stuff up are find the location we're looking for, so the @ symbol, and then use substring to grab everything from 0 up to that. So it says start from 0 and grab me however many characters. If we find 3, then that means we need 3 characters worth of stuff. Right? If I found something at location 5, that would mean 1, 2, 3, 4, 5, 0 through 4 are the proper characters to grab. And then to grab everything after that symbol, I know it's 1 character long, so if I take the location I found it at 3 and I add 1, that's going to be everything else. So I can grab the substring from 0 to where it is. That's the front part. Everything after is the rear. And there are my 2 parts. The other approach I could do would be to actually chop things. Right? So I have myString.find. I copy myString into something called front. And then I erase, for front, I erase everything starting at where the @ is. So this says erase starting at character 3, and I didn't say how many characters to erase, so it assumes from there out. And so front will just be Bob. And then for the rear part, do the same thing, just copy the original string, bob@a.com. And here, I'm going to erase everything from 0, and I want to erase everything up to and including that, and so if I found it location 3, that means I need to erase 4 characters. So 1, 2, 3, 4, get rid of those by saying the index I found it at +1, and so now rear will be just that part. All right, 2 different ways of getting the same exact output, Bob and A.com. It's generally easier to try and work on one piece at a time. Right, so say I want to break up this sequence of digits, and I've got dashes in there. I don't know how long each sequence is, so I'm not going to assume that these are always 4 characters. Probably the most straightforward way to do this, if I want to break this into the 3 components, would be to just worry about the first one first. Right? Find where the first dash is. Okay, that's going to be the location. Now I'm going to grab the substring from 0 to the location, or the location number of characters starting from 0. That's going to be 5033, and I'll call that part 1. And then I'm going to grab the substring that starts at the location +1, so starting right after the dash, and I'll call that the rest. And that'll be 1223-1234. Now I can worry about breaking these 2 up and just completely ignore the fact that 5033 was ever there in this first dash. So how do I do the second part? Well, it's the same as the first. I can just say, okay, find me another dash in this part that I'm working with now, the rest. And once I find the dash, I can say, okay, in the rest, in this new string that I'm working with, get me the substring from 0 up to that second location, and the substring from there to the end. And those are my last 2 parts. It is possible to do this another way, always is. So instead of kind of chopping as I go, I could find the first dash, and then I can say find the second dash by saying find me a dash, comma, start from loc plus 1. So start from one character after where we found the first one. So if we start looking from here, we'll find that dash. And if I know both positions, then I could chop, okay, give me from 0 to that one, give me from this one to that one, and that one on. So I could do the same work, but it does get a little bit trickier because now I've got to do some math to figure out the proper length. All right, the first one's easy, grab me from 0 and start at the look, and I need number of characters equal to the location of the first dash. Then for the second one, I want to start at location plus 1. So I want to start at where this first dash was, one character after there. And the way to calculate how many characters are there would be to take the location of the second dash, subtract the location of the first dash, and subtract one more, because I don't want to include the dash that otherwise would get sucked in as part of that. And so then I can say, okay, start at location plus 1, and go length number of characters, which will get me this piece. And then for the last part, I can say, okay, start at the second dash, add one character, and get me the substring that starts there and goes to the end. A little bit more fiddly, especially if this was more complex and I had a lot more parts to chop off. I would strongly encourage you to focus on doing it more like this. One of your assignments is going to involve chopping up strings, and you're going to be much happier if you work on kind of one piece at a time and keep breaking it into like, here's a piece and here's the rest. Here's a piece, here's the rest.